All right, so welcome back, everybody. Okay, so I just got a question from Victor. Solid slab, flat slab with walls. My child. Okay, I did. Okay, all right, great. So that was the question that I posed earlier on. Okay, all right, great. So solid slabs, then flat slab with walls. Okay, so in that case here, the solid slab will be the heaviest. Yes. The flat slab, then second, then third, flat slab with walls. Okay, all right, good. All right, cool. That's a good attempt. Yeah, in definitely the solid slab is going to end up being the heaviest because when we look at it with the loads of the beams, right, and you know which is heaviest based on those axial forces and the reactions at the bottom. So I don't employ everybody as much as possible to spend quite a long number of time, especially when we get to the aspect of looking at full scale building analysis in the software, because it will determine at the end of the day how would what kind of structural system we end up choosing, right? So great, thank you so much for that contribution. All right, so welcome back, everybody. Wow, we've come almost to the end of the meeting. We're about 30 minutes in. I'm happy that we could stay on track. Let's do a quick recap, right, and then see where we are, right? So remember, we looked like looking at everything in full detail, and like I mentioned earlier on, engineering is more or less kind of trying to break things down to the smallest bits and understanding how it works. So right now, we are about to look at the full scale building, and but what we did is that we started from the start, trying to understand different elements in the building, such as beams, columns, slabs. Then we looked at how different materials affect the analysis of a building, the section as well, looking at the support conditions, and then we also looked at as well different configurations, such as it being a solid slab, being a flat slab, being a flat slab with wall type of building. Now, what we now want to look at it is in full scale, okay? So all of these are not actually practical buildings. When we're looking at practical buildings, it may look something like this. In fact, this is not really practical, practical building. In a really practical building would have most likely staircases, all sorts of openings or different configuration, depending on what it is. But this is kind of the simplest or best representation of what I can show in this meeting. So we have this structural system, but we have stacked stories. So we have different stories over here. Now, we can see that this one here is the solid slab system. We can see here this is the flat slab, and see this one here is the flat slab with walls. Let's look at how all of these results affect our analysis. And the first thing that you want to look at when you're looking at analysis, especially for larger stories like this, is the displacement. Okay, the displacement that are going to be affecting the slab, because ultimately that's going to what to be determining the thickness of your slabs. Okay, let's go over here. If I switch back into this model here, you can see that we have here the full scale analytical model. I'm just going to go ahead and isolate this to make this load quite faster. All right. So we have this one over here, which is the solid slab. We have here, this is the flat slab. And we have this one over here, which is the flat slab with walls. All right, so let's go ahead and look at some of these values. I think I lost my Explorer. Okay, so just waiting for my results explorer dialog box, which is what we use to check the results. All right, so Victor Juma also sent another contribution. Say, how different is C grade concrete to M grade? Okay, okay. All right, so C grade, when we talk about C grade is referring to cylinder strength of concrete, right? And M grade is basically the mix grade. And basically, I won't say that they are different. So for instance, when we see C30, right? When we see C30, that means that is the cylinder strength is 30 megapascals. That's the cylinder strength for the concrete. But when we see M20, that means that is the mixed strength. So M is normally always going to be referring to what is actually done on site. You understand? So that's after the concrete has probably cured for maybe 28 days or more. You understand what is the actual strength when you test it in the lab. But C is something that pertains to it pertains to design, right? So we are not mixing anything. As designers, we need to have standards for the type of concrete grade. So basically they're the same thing, they just mean different things depending on the scenario. Okay, I hope that was able to answer your question. All right, so let's go ahead and look at this, for instance. See, okay. Right, let's go here. So I want to look at the results on surfaces. So displacement, for instance. All right, beautiful. Right, great. So now we're looking at the displacements here, and I should have my map over here. All right, you know what? Let's do this in the software because I want to show you more details in this case. All right, so before I do that, I'm just going to go ahead and turn this off here so we don't have too much graphic intensity on the computer. I'm going to go ahead and isolate this whole structure like this. Alright, so let's edit a new window so we can see these results independently. Let me go ahead and turn off these support symbols to make it easier to view. Alright, good. So in this case here, this is the one with the beams. This is the one with just solid slab, and this is solid slab with walls. So what I want to do here is I want to check here the displacements. Alright, great. So we can see this over here, right? And we can see how the displacement works. You can see here that the higher the building is, the greater the displacement. Now you can only guess the reason for this is because of gravity. As you go up, gravity actually increases, and the building is trying to pull itself downwards, right? Due to the force of gravity. So even though we have similar floors all the way on different stories, you can see that the displacement is higher towards the top. I'm going to turn up with description so we can see. We can see that if I look at the center of this slab over here at the top here, it is about 19 mm in displacement, right? But if I go ahead and let me go ahead and crop the building, so kind of do a little bit of crop. So we just want to crop it all the way to this floor. All right, good. Let's go ahead and apply this. Just waiting for it to load. All right, yeah, so you can see that compared to that value here, you can see how little it is over here, right? So you can see here that the higher the floor is, the greater the displacement. Now in some cases here, displacements are actually neglected because most of the times for higher structures we don't expect it to be so much loaded. So like I said, engineering is all about assumptions, but it's very important depending on the function of the building. You need to understand that the higher you go, the higher the displacement, or rather the deflection on the slab. Okay. All right, good. So let's go ahead and bring back the full building. I want to see it in full scale. I'm going to turn off this map here. And now let's go ahead and look at something vital, which is the axial forces, right? So the axial forces are basically how the loads are transferred from floor to floor to floor to floor to floor all the way to the foundation. And to do that, I'm going to bring up another type of map. Let me come over here. All right, this is good. So we are going to be seeing an interaction diagram, how the loads are being transferred, right? So for instance, let's look at this building over here. You can see somewhere at this point over here, the load here is sent. Okay. The values aren't too precise. Let me go ahead and apply that again. I want to see the actual values. Okay. All right. So we see that at this point here, we have a load of about 13.50. Okay, let me increase the scale. I want to make sure that we have this showing. All right, great. So we have about almost, this should actually be greater than this, but let's just look at the diagram. You can see that at this point here, just like we saw in the other application, the loads coming from this beam and this beam here, they add up to and they increase the axial force. But as we go over here and we come down here, you can see that we have an increase. Now the reason why this increases is that at this floor as well, we also have loads coming from this beam and this beam. You can see that the axial force now becomes bigger. As we go from floor to floor to floor to floor, you can see that it increases all the way to the point where we get to the last floor. You can see it always increases. Now the reason for that is that we expect the load on the column to increase as we are going down. Now if at any point in time you are using software to analyze and you see this is not a clear depiction of it, That means most likely that you've modeled something wrong or you've made a wrong assumption. That's why I kind of emphasize again from the beginning that this basis of structural design is very vital, because it enables you to understand when you're making mistakes or when a building is not behaving where the way it's meant to behave. We can also see similar behavior as well in the structure, but we can see this one here is going to be smaller, right? The values are smaller because we have absence, or we don't have beams, so the loading on this building is smaller. You can see the axial forces here. You can see here that as we're going from floor to floor, floor to floor to floor, you understand they are increasing, but the values here, you can see the last value over here is 1057. Compared to this one over here, this is about 1123. That's about almost 100 kilonewton difference, right? If compared to this structure over here, we can see here that the walls here are going to be sending the loads to the foundations. So we have not turned on the results for the walls, but if you look at the one here, you see this here, this column here is 1270 kilonewton. This one here is 1800, and then this one over here is 1970. So the ones with walls are actually reducing the loads by a lot, right? And which will end up making it easier to design foundations for this kind of structure. So all of this, we take it into consideration. Okay, so let's go ahead and look at the displacement again. There's something I actually forgot to show. So apart from looking at the displacements, let's compare the displacements for different types of systems. So you can see here that, just like I explained earlier on, the one for this system over here, you can see here that the solid slab here has quite a lot of load. We expect the flats to have the most here. Well, the surprising thing is that the one for this structure over here with the walls, it has the least. Now, if you recall very well, remember that we said that it was the solid slab here in the previous model that we showed, that's just with one floor, that had the least displacement. But what we can see here that because of the presence of the walls here, it has helped to reduce displacement as we are going up. Now, the reason for that is that the walls, apart from helping the building to resist lateral loads, it also helps to make the building a lot more rigid and also reducing those displacements due to gravity. So you can see here that it is actually quite smaller compared to this particular structure over here. But you notice at the bottom floor, for instance, let me go ahead and turn on with description. At the bottom floor, you can see the displacement is higher. So you can see this one here is 7. If I come over here, this one is about 5, right? Well, if you go to the top floor like this here, this is why structures is so interesting. If I go to the top floor, we can see that this one is minus 18. But this one over here, if I come over here and move here, it is minus 12. So understanding of these structural systems will enable you to make better decisions when you are designing structures. You can see that the flat slabs doesn't really do the best in these 3 situations over here, but it has its own advantages as well, in the sense that you can actually go ahead and actually have more floors as you're going up. So this is more or less like an architect's dream, you understand, to make sure that you have less obstructions and have multiple floors going all the way to the top. All right, great. So apart from that as well, we also want to look at some things such as the moment diagrams. Okay, so if I go over here and go and look at the diagrams of members, you don't need to worry so much about what I'm doing. We would cover this extensively later on. So if, for instance, I can go over here, I'm going to turn on the moments on the beams and the columns. All right, good. So we can see here the moments on the beams, right? Okay, great. So because this one has beams, you can see moments are both generated on beams and the columns. But we can see here that in the case of the flat slab here, we can see here that the moments are only generated on the columns. In the case of this one here, it's just generated on the columns. Now I'm looking at the moments in just one direction. If I decide to change it here and look at it in the other direction, it will visibly show you where the moments are generated in those other directions as well. So all of this, we pay attention to it because it will end up determining how large your column sections are or how large your beam sections are going to be. All right, now let's go and do something else. So we looked at the axial forces of columns, but at the same time as well, we need to also look at the forces being transferred from the walls all the way down, because basically walls also do the same things as columns in sending the loads, apart from resisting the lateral loads like winds and seismic loads. They also transfer the loads from the floors to the foundation. Now we check that one in a different way, and how they send the loads is quite different from columns because they distribute it over an area. So let me go ahead and check. Oops, not this. All right, so in this case here, I'm going to check this. All right, so we can see here that we have a pattern, right? So in this case here, you can see here that the load is coming from the wall, and as we are going down, it is going to be increasing. All right, now it is going to be spreading it out as much as possible. So you can see here that over here now, as we go down and take a look at the scale at the right or bottom right of the screen, as we're going down the building, that value is going to be increasing, right? So at this point here, it is increasing, 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 increasing all the way to this point here. Meaning that the same thing that also applies to columns applies to walls as well, right? In terms of section. So what that means is that if a wall, for instance, has a width of, let's say, 200 mm at the top, due to the amount of loads that it's carrying, at the bottom, for instance, you notice when they are stacking walls, at the bottom here, we can have something like about 400 mm thickness, maybe 600 mm thickness, you understand, just because of the loads it's carrying. Also, the same thing also applies to columns as well. Okay, all right, let me turn this off. All right, so the same thing applies to columns. So the more loads that are coming from one floor to the other, right, it will lead to an increase in column section. So maybe to practically demonstrate that, let me show you like how it looks like here. So for instance here, let's say this particular section works here, but if let's say at some point in time it becomes so massive for the building, I can decide to go and change this column section to something that can support it better, right? So that's why you notice in building structures, as you are going down, the column section may end up increasing, right? May end up increasing something like this all the way to the bottom. Okay, and it may not just be just once, it can actually happen twice. So for instance, you can have something like this. Let's say you can have something like this until you actually take it all the way down successfully. All right, great. So we've been able to now cover all of this so far. All right, now let's go ahead and do a quick recap before we actually go and address some questions and call it a meeting end, and then we'll do some other things. So we have here we started like looking at everything from the smallest details, such as looking at beams, taking into consideration different sizes, their support conditions, as well as different configurations. Is it going to be simply supported or is it going to be continuous? Then we also looked at columns as well for the same thing. If it's going to be loaded axially, just point loads at the top. If it's going to be loaded at the sides as well, so that is going to be bending in one leading to bending in one direction or two direction. And we looked at members subjected to torsion. In this case here, we looked at when the beam is loaded not just in just one direction, it's loaded in another direction as well. We also looked at as well slabs. We looked at how different thickness determine the design criteria for slabs. And now looked at structural systems in the smallest details. So looking at solid slabs, we looked at flat slabs as well. We looked at flat slabs with walls. Then we now looked at the building in full details like this. So we're having multiple stories. All right, great. So with this, we'll be able to establish how buildings should actually behave under loading and how it will affect our design at the end of the day. Now we're going to be using most of the knowledge that we've learned in today's meeting, continuing on when we go ahead and start our design projects. All right, good. So it's been quite an engaging meeting, and I hope everybody actually gained quite a lot. At this point here, I want to ask if you have questions. If you have any questions, feel free to send them in the chat box. If you want to speak as well, feel free to unmute yourself and speak. Okay, so before I address the questions, just want to send out some notes as well. So it's very vital that everybody is fully participating in the program, and that will be the major requirement at the end of the day for certification towards the end of the program. So like I mentioned earlier on, especially for those that didn't catch it or entered a bit late, every single participant has been assigned a project folder. So that is actually a cloud folder, a Google Drive folder, and inside that folder you will have access to a logbook. So for instance, now what we've done in today's class, that is actually Saturday, you are meant to go ahead and document all those details in your logbook. Okay, and now your logbook is going to be one of the major criteria for determining the certification, just like I mentioned earlier on. So everything you've learned, just feel free to actually go ahead and write it down. Like I said, if you have questions, just feel free so let me know as well. I'll address them. You can send them to the general channel on the Slack platform. In fact, I do encourage that you do that so everybody could learn. Or if not, you could also send me a direct message. I'll be glad to also enlighten you in that area as well. Okay. All right. So let me see. So okay, yeah, so Vivian said it very insightful session, sir. Thank you, or thank you very much, Vivian. Glad you found it insightful. Right, so Victor said kindly guide. How do we log the Saturday classes? What are the log sheets? Okay, the log sheet ends on Fridays. Okay. All right, so we apologize for that. We would most likely modify it. So what you do in this case is that if you are familiar with using Google Sheets, you can go ahead and add those rows, you understand, to accommodate for Saturday. If you're not familiar, most likely I would have our executives work on the sheet so you can do that. But what you can do for now is just change Friday to Saturday while we work on updating the sheets to make it better to use. Okay, so just change that Friday to Saturday and as well document the data as well. All right, so once again, I appreciate everybody for joining. We look forward to having more programs. So our next program is going to come up on Monday, probably about the same time, but more information will be sent now as well. I do recommend that you have your Google Calendar set up in Slack so you receive notifications when meetings are scheduled. You will also be able to see future meetings also being scheduled ahead of time. Now we are going to be starting our next meeting in Revit. Okay, so we're going to be going hands down into the software. Now this is a very good opportunity for me to ask if everybody here has gotten this their student license activated and if they have downloaded the software. So let me just ask if you've gotten that. If you've done that, just let me know. Let me see yes. If you haven't, just let me know as well, so we will be able to guide you on how to get the software, because it's very vital as well. We want to make sure that everybody is practicing and has a product at the end of this design workshop. It won't be a design workshop if you don't have something to show for. So if you do have either one of the two, it's fine. If you don't have them, just let me know. So if you don't have the software, just say no in the chat box. If you have it installed, just let me hear yes in the chat box as well. So just going to be waiting for that response. Okay, so Vivian said no. Okay, Waxike said yes. Okay, so let me wait for the a more general response. Okay, Monet said not yet. Okay, great. And Debra said yet to install Revit, but I have robot structural analysis. Okay, Anthony said no. All right, great. Okay, yes, all right. So also I do advise as well that you are using either the 2020 you're using either a 2024 or a 2025 version, because most of the project files are going to be there. But if you are using a lower version and you can't upgrade, we'll try as much as possible to make older models available as much as possible. But it will be better if you are working with newer versions, so either 2024 or 2025. The reason for that is that it has more features, and that's what we'll be using in cases of presentation. Now you do not need to worry about system specifications, as Revit and robot structural analysis are actually very user friendly with the computer. So higher end versions do not actually take so much processes on your computer. I can actually attest to that. All right, so yeah, so it's been a great meeting. I appreciate everyone for joining. Let's call it a close, and then I look forward to seeing you during our next program. So make sure to fill in your logbook. We would actually be checking that quite shortly. And like I said, if you have questions, feel free to let me know. Do have a lovely weekend, all of you, and I look forward to seeing you next time.